Okay, the next problem, compound interest. We're going to use the formula that's on our formula sheet for that, which is right here. Plug everything in, the interest rate as a decimal, 4 calculations per year for N, 17 years for T, principal value 4,800. You do get this. And you can do this in your calculator as well with the TVM solver we used. Plug everything in, 68 total payments, 4 times 17, interest rate, principal value, payment, and then if you hit alpha equal on the final value, you get the same answer. Okay, the next problem, we're going to do the same thing, only this time it's compounded continuous, so we're going to have to use the continuous formula here. And if we just plug things in, we could find out how long it will take to triple and become 37,500, which is what you get when you triple this. And when you divide both sides by the 12,500, you obviously get 3 equals e to the 0.09t. Take the natural log of both sides, and you get 0.09t equals natural log of 3. And then just divide by 0.09, and our answer ends up being a little over 12 years. Okay, solve these without a calculator. Now I know on the exam you can use your calculator, so it makes problems like this really easy, but 5 pi over 6, if you break 180 or pi into 6 parts, you got 5 of them, which is over here, which means that this is, pi over 6, this little angle right there to there, which means that's a 30-degree angle. You know where that's at in your unit circle. The sine value for that point is 1/2. So our answer is 1/2. Next problem, negative pi over 3 is negative 60. You can convert it if you want, but that's a 60-degree angle. And your unit circle values there are 1/2 negative square root of 3 over 2. Now secant's the reciprocal of cosine, so cosine's 1/2, we want to reciprocate that, get 2. Okay, the next problem, 270, we're talking about down here. The cosecant, the sine is negative 1 there, the cosecant's a reciprocal of that, so 1 over negative 1, which is still negative 1. Okay, the next problem wants to use the right triangle to determine the values of all the trigonometric functions of theta, where it gives us the tangent of theta is positive 15 over 8. Now, this should have been a little more specific because you could draw this reference triangle or this one because the tangent's positive, but tangent's sine over cosine, so it could be, the double negatives cancel here. But let's just ignore that. Let's just assume we're in the first quadrant here. Let's do the Pythagorean theorem. You get 17, so now we can do the cosine, sine, tangent, as well as the reciprocals. So I'll spell these out for you. Cosine is adjacent over hypotenuse. Sine is 15 over 17. We already have the tangent. We just flip those to get the reciprocals. Okay, solving this right triangle for 39, we know that this is 35 and this is 15. So I can do the cosine of 35 equals adjacent over hypotenuse, multiply both sides by 15. That gives me B. It's about 12.29. I could do the same thing with sine for A. You get about 8.6. And if I take 180 minus 90 minus 35, I get what beta is, which is 55. So I can write all that out, and there's my answer. Okay, so next problem, if I graph this point, negative 3, 6, I can draw a reference triangle here. Do the Pythagorean theorem, get the hypotenuse. It's usually the square root of 45. So now I can write all the trig right here. The cosine is adjacent over hypotenuse, so that's negative 3 over the square root of 45. Sine is opposite over hypotenuse, 6 over the square root of 45. And then tangent's opposite over adjacent, which ends up being negative 2. And just flip these to get the reciprocal. And there's your answers. Okay, the next problem, we're looking at this function. We're looking for the amplitude, period, phase shift, domain, and range. The amplitude is obviously 1.5. The period is equal to 2 pi over b, which in this case, 2 pi over 2, which is pi. The phase shift is what you're subtracting from x, but I have to factor out that 2 and get x by itself. So if I do that, I get pi over 8 here, because if you distribute the 2 goes into the 8 4 times. So it's actually pi over 8 for my phase shift. And then last, my domain and range. We know sines look, they're like that. So the domain is negative infinity to infinity. And the range goes up and down from the amplitude, so it'd be negative 1.5 to 1.5. Next problem wants to find the exact value without using a calculator, which obviously you could use the calculator, but let's graph this real quick. All right, we're between 90 and pi, and the sine is 1/2. So that should look familiar. This is a 30-degree angle right there. That's 150 or 5 pi over 6 if we're in radians. Next, I want to evaluate this expression without a calculator. Let's take that inverse sine of 3/5 and let's set it equal to theta because it really is an angle. Let's then do sine of theta equals 3/5. and take a look at where that would be. We know it has to be, in one of these two quadrants because that's where the inverse sine is defined in our domain. So if we look at opposite over hypotenuse 3/5, this would be 4 if you do the Pythagorean theorem. Now we can find the tangent is opposite over adjacent, so our tangent is 3/4. Next problem is pretty easy. It says the angle of elevation, the top of the building at a point 100 meters away. They've given us this angle then right here is 78 degrees. And they want us to find the height of the building. Got a right triangle. We can do opposite over adjacent. So we can do tangent of 78 equals opposite over adjacent and multiply both sides by 100 to get the height, which gives us about 470.46. Next problem is pretty similar setup, only this time you have an angle that's in degrees minutes. So you can convert that in minutes because we know that there's 60 minutes in 1 degree, or you can use your calculator and just do the same thing, opposite over adjacent, multiply both sides by 62, and then just when you plug this into your calculator, plug it in like this. 62 tangent of 72 degrees, so go to second angle and hit the degrees, and then do 24 minutes. So once again, go to second angle and do minutes. And then just make sure your calculator is in the right mode. You want to make sure you're in degree mode here, which I am, so I can hit enter, and that gives me my answer of 195.45 feet. Next problem, find the algebraic expression equivalent to this right here. Well, we know that that the inverse tangent of x equals some angle theta. So that tells us that the tangent of theta is equal to x. So if we try to graph that, we can make a reference triangle that's in the first quadrant here. And tangent of theta, this is our angle theta, would be adjacent over hypotenuse, which then makes this the Pythagorean theorem, square root of x squared plus 1. So when they want us to find the sine of this angle, now we can do opposite over hypotenuse. So my answer would be x over the square root of x squared plus 1. And I guess the only question is, how did I know to put my reference triangle here? Well, that's just because my range of tangent is between negative 90 and 90. That angle that I get out has to be between negative 90 and 90. We know it was positive x, not negative x, so I drew it in the first quadrant, not the fourth. Okay, 5155 is using the law of sines to finish off this triangle. And they gave me angle side, which is a congruence theorem from geometry, which means that there's only one triangle that can be made. That makes it pretty easy. So we can set up the law of sines, just do the sine of angle A over side A equals the sine of angle B over side B. So once you multiply both sides by 7, divide both sides by sine of 79, and multiply both sides by B, you get 3.88 for B. And then you can find this angle by doing 180 minus these two to get this as a 68 degree angle. And now do the same thing with C. So, just start over with C. And same solution, you end up getting about 6.6. 55 is similar, which is the law of sines again, so I'll skip that one and let you do that one. But 63 is a little different. They give us this picture here, two observers, the angle of elevation, the distance between them. They want us to find how high the balloon is above the ground. Now, what I would do is, there might be other ways to do this, but what I would do is find one of these sides right here. I'll find this side right here, I'll call that x. And I'll find it with the law of sines. So I'll do sine of angle 37 over its opposite side, x, equals the sine of this angle right here, which is 110 if you take 180 minus these two, over its opposite side, 1.75. Now if you just cross multiply and solve, you get x equals about 1.12 miles. Now I'm not going to round that, I'm going to keep that in my calculator, but now you can see I have a right triangle here where I can do the sine of 33 is equal to the opposite side, h, over its hypotenuse, 1.12 miles. Multiply both sides by 1.12, so basically I'm going to take that number that's in my calculator and multiply by the sine of 33 to get the height, which is about 0.61 miles high.